everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today I've got Sarath Kumar who has just completed the course Linux Basics for Robotics and he'll be giving us a presentation on this. So what I'm going to do is to hand over the platform to him so he can begin his presentation. Alright, whenever you're ready, Sarath.
Yeah, just give me a second. I'm just going to place my robot there.
Okay.
Yeah, it won't take long, like a couple of seconds, and I'll be able to. Oh, okay, yeah, that should do. Okay, yeah. Mm.
Alright, so
So I can
let's go.
start.
Let's go. Yes.
Okay.
Alright, so we want you to be explaining what you're doing and you can give us a preamble
Okay,
to
yeah.
that in case you do an action that we do not understand. And you can assume we don't know everything.
Okay. Yeah, okay. So I could just go with the flow or uh, with explanation in the what do you call, like in the presentation.
Mm-hmm. Yeah, so just make sure that you don't forget the presentation, right? I won't say no or yes. Just make sure you don't forget the
Okay,
demo
okay.
because your time will run out on the robot. So whichever way you're comfortable with, manage your time correctly. That's the important thing.
Okay. It's like in the presentation, I put like uh, everything in all together,
Sure,
like
sure.
with the explanation there. Okay, yeah. So I'll just run the commands here. So
Can you explain to me why you chose to build in that folder?
yeah, okay. So just I'm setting up like the those packages in rows 2. So call can build like, cause like I used like couple of packages here. So a wall follower is one of them, and there is a custom package I use. So uh, it's like letting rows to know like those packages exist.
Yes, I'm just worried about the location in which you build.
Oh, okay, yeah.
So where do you normally should build? At least as per the
What is
course.
that?
Where, like, where do you build the
Because like
material
it's
that you
under,
have planned, right? It's not in there, I will tell you that,
yeah.
right? It's not in the source directory. You build somewhere else.
Okay. You mean like how do I know where it is?
No, where do you? So where you call the command matters, right? For the
Yeah,
sake of understanding your
yeah.
workspaces, right? And my question to you was, given that I've told you that you shouldn't build in the source directory or the SRC directory, where should you build?
Sorry, I'm like not getting the question. Like, what should I build, or like,
All right,
or
no
where
worries.
to
So
go?
let's proceed. Let's proceed. I want to see
Okay, okay,
your
okay.
implementation at
Yeah,
this point.
yeah. There's like a couple of obstacles on the way, so I'm not sure like how it will respond.
Okay.
Yeah,
Okay.
because like it's dictating the.
Yeah, that's understandable. You can stop it now and
Okay,
and walk us through what you did. Anyways, by the way,
with
we are
the slide.
supposed to build in the workspace, not in the source directory. So very important to note.
Okay, okay.
Yeah, and can you also explain which custom interfaces you wanted to build and why you had to upload them from your local machine?
Because like for the find wall for the service server and for the custom action, I used like the custom packages which I have created here. I should be able to see it now. Yeah, there is the custom interfaces, and I included like action and also the service here, the find wall service and the
Okay,
autumn record action here.
I see.
So, and under the wall follow package, I have the autumn recorder just like as in the name as its requirement, wall find and wall following.
Okay,
Right.
so let's do something here. So I think this will also will help you before you get into your presentation. So I want you to go to your terminal and remove all the build folders that you have put in your SRC folder.
Okay.
Yeah, so you know how to do that, right?
Yeah, you want to go back, right? Okay.
No, no, no. I want you to remove the build, log, and install in that SRC directory that you built in.
Uh, do you want to remove or I didn't get that part actually.
Yes, I
Sorry.
want you to remove them, right? So rm stroke rf, and then you specify the folder build, install. You know the command, right?
Oh, okay.
Yeah.
Oh,
So
yeah. Okay.
yes, navigate to the SRC folder in the ROS2 workspace.
You mean like I could drag it from here, right?
No. Okay.
Okay.
I in
So
the
it
terminal.
won't work, right?
It will work.
Okay.
That's why I want to show you. But anyways, I don't want us to waste time here. But the point I'm trying to
Okay.
illustrate here is you always
Okay.
build in the source folder, right? You don't build in the SRC directory. Otherwise, you will overlay some workspace specifications, right? And it's also a bit confusing
Okay.
to other
Okay.
people, right? So even if you have a
Okay.
nested package, like in your case, ROS2
Hmm.
will build those packages for you. So I wanted to show you that you shouldn't be worried about the fact that my packages are nested or they are within a directory which is maybe one after the
Okay. Okay. Okay.
yes. Anyways, now let's go to your
Okay.
presentation and then you can explain what we have just seen on the robot.
Okay. Okay. Yeah. I'm just. Are you able to see my screen now?
Not the presentation. We're still seeing your browser.
Okay. Yeah. Yeah.
Okay, now we can see
Yeah.
your
Can you see my
presentation.
screen now?
Yep. Mm-hmm.
Okay. So I could start now, right?
Yeah, go ahead.
Okay. Yeah. Hi, my name is Sarath Kumar Kamtgatil. I'm here to explain my ROS 2 wall follower in that I have performed. So it makes use of the topic, service, and actions. Section 1, it was on the topics. The wall following, it used a laser scan And the goal was to keep the robot within the minimal distance from the wall, and it has to follow the wall. And section 2, it was on the service. It was like automated wall alignment. So the goal was to keep the robot in a position, and it has to align with in a direction in such a way that the wall is on the right hand side. And the section 3, it was on the actions. It records the odometry, and thereby it gives the feedback on the total distance covered and everything. Section 1, it was on the wall following, as I said. So the control logic, it was like it has to the robot has to keep a minimum distance from the wall. So if it was greater than 0.35 meter, the robot was made to turn right to keep the distance. And if it was less than 0.3 meter, it has to turn left to move away. And if the distance from the side wall, from the right hand side wall, it was between 0.30 meter and 0.35 meter, the objective was it to make to go straight. And when there is a front wall head, and if it is less than like 0.5 meter, it has to make a quick turn, like turn faster, to follow the lane. And I have seen like there was two setup was used, one for the simulation and for the real. It seems to be different. I'll be explaining more on the challenges later at the end of the slide. So the total race was like 720 for the simulation, and for real it was close to 450. And right ray index it was 539 for the simulation and 336 for the real. And front ray index it was like 0 for both. And the publisher topic, it was like different for both the simulation and real. And the front threshold, it was like set a different value for both the simulation and the real. Um, Section 2, it was like the find wall surveys. And I created like as per the requirement, and a service file was created. Like it has got like no request, but like the response was like like a wall found boolean was used. And sorry. Okay. And the first was to it is placed. The robot is placed in such a way that the wall is on the left hand side in the beginning. So the first it has to make use of the use. It gets the laser details from the topic scan, and so it gets an idea of like the obstacles around it. So the of course the closest will be the one on the left. So it spins in a way that like the nearest obstacle is to the front. So and a minimum distance is being maintained from the wall, so that in a way the robot is like facing the wall within a distance of like 0.35 meter. Once it happens, the objective was to move the robot to the right, so that the wall is on the right hand side. So it has to like turn like 270, I mean, like in the clockwise, like 270 degree, to make the robot facing the right wall.
Okay.
And section 3, it was on the actions like the odometry recorder. And why like an action was used not as service, as like the duration. It was like a long duration, and we need like the feedback every second, as like we are calculating the distance traveled by the robot like every second, and to measure the total distance it covers in a lab. Okay. And this was the order action that was used as the objective. The goal was like empty, and like the John it a list of the items like the positions and everything. And how it works was like it saves the first order position, and then record like the x, y, and theta, and it add to the list every single second. And it also publishes the total distance it travel by calculating the distance. And the lab detection, is like when it completes the one lab, the odom record action should be stopped. So that's like, so when the distance from the start is like kept between from the 0.1 meter from the starting point. But in the reality, I had to keep it at like 0.5 meter. I'll explain more that in later. That was done in the challenges section. And this is the system architecture I have used. Like we had like the wall finder, the odom recorder, and the wall following codes. Like the wall following, it is the master code that we use. Like it acts as like the service client, action client, and it subscribes to them the subscriber topic laser. And it is the one that controls them, set to be control both the service server and the action server. It's initiate the wall following the code, like it's initiated with the find wall service. The find wall service, it aligns the robot in a position. And once the robot is in position, the position is like the wall is on the right hand side. That's the position it was after. And the and then the record odom action, it's initiated. It's being called, and it records them. It records the odometry to for the entire lab. And then comes the wall following is like initiated. And the roster the topics used was like the scan for the wall following. It was used in wall following and the wall finder, and the CMDVL. It was used in the simulation, and whereas in the real it was like CMDVL underscore scale, and the odom was used in the odometry. And the challenges I have faced was the invalid laser readings. That was in the real robot. I believe it's due to some technical glitch. It was showing the false reading like 0.8 meter. So I had to bypass that. So I had to keep the and keep a statement to remove the 0.8 meter. It was like giving a false statement, and filtering the readings other than the 0.08 meter. And I also found that different laser indices was for both the real and the simulation robot. For the simulation, it was found to be 720 rays. I found it through the by using the echo code like in ROS2. So I get the minimum angle and the maximum angle, and I got the angle increment. So then I just subtracted like the maximum angle minus minimum angle by the increment, and I find that the total number of rays was found to be 720 and 450 for both the simulation and real. And the right index, it was found by it was like 270 degree. It's 270 degree. So 270 divided by 360 times the number of rays gives the right index for both the simulation and real. Uh, and also, as I discussed, like the topic like CMDVL was used in the simulation, CMDVL safe assist in the real. And there was some TV and odometry shift, as there is I believe it's like the real wheel slip, like the position, like the lab couldn't be found to be completed, as the robot never returned to within the 5 centimeter of the start point. So I increased the tolerance to 10 meter to
Okay.
uh, measure the lab completion.
And did it work?
So, yeah, it did work.
Okay.
And like three concept was, as I said, like topic, service, and action was used, and like two platforms, gazebo simulation and the real turtleboard robot was used. And the average lab distance, it was found to be like 5.5 meter. And the key learnings are like the multi-thread executor was used along with the callback groups, which is essential for executing the parallelly, and rear-end callbacks needed when action callbacks must be it must be run alongside the subscriber. It was noted. And the simulation, it was never like a copycat applicable in the reality. That was one finding. And the real robot always needs tuning for it to work in real conditions. Thank you.
Okay. Thank you very much, Sarath. So, anyway, let's get to some questions, right? So, there are a couple of things that I want to ask you about. So, you spoke about the use of services and actions, right? And there is not
Yeah.
there is not much reason to choose one over the other when the understanding is not there of why you have to use one over the other. So can you explain to me in a bit more detail why for odometry you had to use an action, whereas for finding the wall you had to use a service, right? Let's dwell on that. I wanna fully understand what's the backing behind your reasoning to choose a service for one and an action for the other.
Yeah, the reason for selecting like the action was like we need like the feedback like every second. Like if I use like a service, I won't be able to like get a feedback constantly. I mean, for that purpose, like the because as we calculate the distance from the initial point, like every second, so we got to use the action for that.
Okay, okay, that's about the action, right? But what about the service,
Yeah.
right? What about the service? It's not all about feedback, right? A service does not give you feedback, yes, but then what makes you not use an action to do what a service was doing? Because I'm quite sure it can work.
Uh, it was yeah. Uh, uh, Yeah, um, I believe like
Okay, let's
uh,
let's talk about a
yeah,
service in general, right? What do you understand about a service? How does it work, right? And then from there we can start to try and reason in this direction that I've asked you, right? So give me a general description or a general explanation of what you understand about a service and how it works.
yeah. Services like service like it has got both the server and like the client side. So the service has got like a server has got like it has got a request and a response thing.
Mm-hmm.
So on the basis of the on the request, like it gives a response to the client. So
Right, that's correct.
yeah, yeah.
How does it differ from topics?
How does it differ from
From
topics?
topics as a channel of communication, right?
Oh, okay. So this is like the response is like only get like topics is like it's always like uh, it's I, I mean publishing like anyone can any node can get use that, but like service is something like specific only to that response. Sorry, only to that request it's giving the response.
Right, okay, that's one part. So you've got one part correct. There's one part that's still missing, right? And that is very much relative to an action.
Uh,
Like go
on
back
the
to,
service.
yeah, go back to how you use
Yeah.
it for all detection, right? There's something very important about how it works that makes you want to use a service, and that also stops you from using topics for that. So can you
Yeah,
dig
because
deep?
like we mm, yeah, so that it's only being used when it's like needed. So topic is like it's always on action. So service like only when there is a request, there is a response. So
Right, right.
uh, it 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 keeps the it keeps
Yeah, I
it
think
more
I think
yeah.
I'm happy, right? With some help, you got to where I wanted you to get to. So I would say you can be grateful about that. I wanted you to
Okay.
go to this part where you fully understand that with the service, it's a it fires once, right? It only gives you an answer when you want one, right? And
Yeah,
that's,
yeah, yeah,
yes, so that's the main reason here, because your service for discovering the wall in this case will only be triggered in the instance when the robot is trying to find the wall. After that, it's not being used, right? It's not
yeah.
being used for any form of control whatsoever. So there is something niche about a service, and that is the one part that I wanted you to add to the other element about its difference from topics. So um, I'm happy with it. Now let's go to the other
Okay.
bit, right? The other bit that I wanted to ask you is, if you were going to make changes to your code to make your robot go, this time it was going counterclockwise. If we're going to make it go clockwise, can you show me in the code base where you'd make those changes and explain them in detail? You've got about 3 minutes.
You mean like in the wall follower or like
In
finding the
in the
wall?
wall follower, right? In the wall follower, right?
Okay.
Obviously, you probably would have to make changes to the wall finder because you want it to rotate the other way when it finds the wall. But I'm more
Yeah, because
concerned
like
about the following. Yes.
oh, okay, okay.
Yeah. So let's go to
You
your
mean
IDE and you can
okay,
explain
okay,
from there.
yes,
Yes.
okay. Sure. I just gotta log into the thing again. It's seems to yeah, are you able to see it now?
Yes, we can see it.
Okay. Yeah. Here it's uh, the negative is like for the for rotating it to the right hand side, and like the positive it's to rotate it to the left hand side.
Okay, all right. So that's on the angular side of things, right?
Yeah.
I wanna understand more on the scan side of things, right? So that's the way you're processing your lighter scan ranges. That's the part that I really want.
Okay. Yeah.
So can you
Uh,
find that section? Talk me through that and help me understand.
uh, and the confusion is like so you are thinking about the wall following, right? So once the robot aligns with the wall,
Mm-hmm.
not the find wall thing, right?
Yes, yes.
With the find wall.
Okay, so let me simplify it for you. So
Okay. Yeah.
are you using a particular index to keep track of how close your robot is to the wall, right? When you follow the wall?
Yeah. When I follow the wall, it's like I check for the you could see it here 336 distance to the side wall. That index is used.
Right. So, relative to that, what changes
Yeah.
would you make to allow for control on a clockwise loop instead of a counterclockwise?
Yeah. Okay. So it will be like 90-degree to the left. I mean, so it will be, I got to find it by 90 by 360 into 700. That gives the index for the left-hand side.
Right. So that value also change, correct?
Yeah, that value changes. 366 will be different.
And relative to the placement of the lidar, where would that value be on the robot?
Uh, I didn't get that. It will be 90-degree clockwise.
Right. So you are monitoring the which side of the robot?
I mean, now it's on the, in the code is like focused on the right-hand side, right? So it will be like uh, a 90-degree to that. So 90 by 360 times, that will be the index I'll be using there.
Right. So you'll be monitoring the left hand side of the robot, correct?
Yeah.
Okay. All right. All right. Thank you very much, Sarath. So what we're gonna do is we're going to wrap it up here, and we'll finish our conversation on Zoom. Okay.
Okay. S- yeah. Okay. So is there anything else you want
All right, everyone. This was Sarath's presentation, and I'd like to encourage all those of you who would want to try this course, ROS 2 Basics in 5 days, to do that, and you can